All right, let's get started. Welcome back to the post-lunch sessions. This is a place where we try our best to lull you back into sleep. Please work with me in doing that. A quick overview of who you are. I'm Vinod. Um, I'm the Yarn development lead and architect at Hortonworks. I also lead Yarn project in Apache. I'm 7 Hadoop years old, where Hadoop years is defined as the time since Hadoop started. And you'll only find people who are probably close to 8 Hadoop years old. So be wary of job advertisements which ask about 10 years Hadoop experience. I see that a lot. And I am also part of the Hadoop PMC. Yarn is part of the umbrella Hadoop project. And most of the code, about 99% of it is in the open source. Together with me is Mr. Jian.
Hi, everyone. I'm Jan. I work at Hortonworks also. And I'm right now a Apache Hadoop committer. And I mostly focus on Yarn and MapReduce development. Yeah.
Thank you. All right. Before we go into the details, a quick show of hands. How many of people have used Hadoop here? Depending on that, we can figure out what we should talk here. OK, that's quite a bit of people. How many of you have used Hadoop 2 and Yarn? That's about 50-50. And in the 50% of the people, how many of you used Yarn only for MapReduce applications and not much more? That's a small fraction. So everybody else in the remaining 50% are using Yarn for something beyond MapReduce, I would suppose, right? OK, that seems like the right mix of audience. So a quick summary of the agenda. We'll start with a very brief overview of Hadoop 2 itself for the 50% people who are still on Hadoop 1 and not yet moved to Hadoop 2. And then I'll give a very brief update of the Yarn community. Like I said, Yarn is part of the bigger Hadoop umbrella project. So we have communities and sub-communities within the umbrella community. I'll give a very brief summary of what's cooking there. Jian will then talk about all the present stuff, present features in Yarn, stuff that's already shaped, things like that. And then we'll finally wrap up with looking into the future. All right. So overview of Hadoop 2, right? You might have heard a lot about Yarn in the morning keynotes and lots of sessions, right? If I have to summarize it in a slide, that's what it is. This is the resource management platform for apps that can run on top of the same cluster, run on top of the same data sets, right? We implemented MapReduce v2 to run on top of Yarn, and the primary goal of Yarn is to evolve the compute platform to be beyond MapReduce. And in line with that, new projects sprang up, like Apache Taze, Storm, which is running outside in its own cluster, that's moving slowly to Yarn, and we also have Spark, right? On top of that, so Spark, Taze, Storm, these are what we call the regular job kind of applications where they run for a while, they go away. And increasingly there are a bunch of applications which all want to run on the same set of same hardware, same cluster of machines. At the same time, taking leverage of all the great things that Yarn is giving you, right? Increasingly, things like HBase, things like Accumulo, basically long-running services which existed before Hadoop or separately from Hadoop. And typically the installation pattern is install HDFS and Yarn in one set of the cluster and run HBase in a different set of clusters, right? So we are seeing a pattern where all these running long-running services also want to share the same set of cluster, because managing multiple clusters would necessarily mean losses in utilization, elasticity, and stuff like that, right? So that's the single slide which should explain what Yarn is. It's a data operating system. You have data underneath living on HDFS, and Yarn provides platform capabilities on top of which you can run batch processing, you can run interactive processing, you can run SQL, you can run stream processing, graph processing, and so on. Essentially, you bring data in one single place and do whatever you want with it, run analysis in different paradigms, don't restrict yourselves to MapReduce, pick the programming language of your choice, and so on. And that's the summary, right? Now, why should you move to Yarn? If there are 50% of people are still on Hadoop 1, right? Why should you move? We say that Hadoop 2.0 is at least twice as good as 1.0 in various sense. It has better scale. It is built for today's and future hardware trends, right? We originally, even when we started Yarn, our goal was to run it on a 10,000 node cluster, right? So that's the scale we are looking at. There's also agility. In Hadoop 1, you couldn't evolve the compute platform together with MapReduce layer, but given we now have MapReduce, you have Storm, different paradigms, different applications, you want to evolve the applications separately from the platform, and that is increased agility, that's coming with Yarn. And finally, even if you don't use any of that, if you just stick to your existing workloads and applications, you get twice as throughput as before because of the efficiencies, because of the better architecture, right? And I'll go through some of the profiles from different companies. Yahoo, who's been a leader and visionary in all things Hadoop, they have deployed one version of Yarn. This is not Hadoop 2.0, but it's based off a 23 branch. And they're moving very fast to 2.x. And the first versions that they have deployed in their production clusters, it has increased their utilization by about 50%, right? Essentially, their biggest cluster is no longer the biggest cluster. They can do more on a smaller set of nodes. They have increased their job load from 80,000 per day to 125,000 per day. This was a while ago. This was last year's. I don't have insight into the current day stats, and it's very likely they'll blow my mind too. But the summary is they've seen that they can utilize clusters much better. They can run applications much faster, right? Continuing on, Twitter also deployed Yarn and Hadoop 2 in production this January. They're running about 2 million jobs. They ran 2 million jobs back then, and I was just having a conversation with them. They have much more now. Lohit and Gera from Twitter, they are presenting about Hadoop 2 and Yarn's usage at Twitter. You might want to edit that. And finally, eBay, who also have one of the largest production clusters of Hadoop, they have anywhere from tens to hundreds of petabytes of data. They have migrated to Hadoop 2, and they're also seeing similar improvements in utilization, performance, and so on. So that's overall, kind of a rough trending of how people are using Yarn, what advantages they're getting out of it. And remember, I was asking, I was saying that there are people who are using MapReduce alone on top of Yarn. There are people who are moving beyond MapReduce, right? And all the stats that I've given you so far is just MapReduce on Yarn. So even ignoring the rest of the benefits that Yarn is giving you, just using MapReduce on top of Yarn itself is a huge win for all the customers, both in terms of utilizing existing resources, getting performance out of it, that it's a non-brainer to move to Hadoop 2 and Yarn. So a quick summary of where the community stands today. We have done a lot of releases. The official release, the first GA release happened in Hadoop 2.2, in the parent Hadoop project. 2.1 was where we were still in the alpha stage. You can see that 350 patches went in, which were mainly about stabilizing Yarn, solidifying the API such that we can build a solid future. 2.2.0 was the first GA release of Yarn. 2.3 and 2.4, they were bug fix releases, and we added a lot of enhancements. Jian will talk deeper into what went into each of those releases, and we are marching forward. Contributors from the contributors' point of view, we have about 105 contributors and counting. It increases day by day. There are a few very big contributors who do the big stuff, right? And then there's a long tail which who take care of stabilization, smaller features, and it's a very vibrant community. I'll hand over to Jian for covering all the stuff that went in the past and present.
Thank you. Okay. So next topic, I'm going to talk about the major features we have done in the last couple of releases, and also the present major work we are actively working on now. Okay. As we know that, so the first release, the first GA release was the Hadoop 2.2. It was last October, and we did a bunch of work there. Basically, the major work we have done is to stabilize the APIs so that application writers will not need to worry about the compatibility, API compatibility issue anymore. And hopefully, this is the last time we break the API. Yeah. Also, the other thing we have done is the binary compatibility for existing 1.x MapReduce applications. This means the previous MapReduce applications that were running on top of 1.x will just be able to run on top of Yarn Hadoop 2.x seamlessly, and the simplest thing people need to do is just to point the configuration from 1.x to 2.x, and all these applications should just be able to run successfully. And we also did a bunch of scalability testing. And as people know, Yarn has completely transformed from the 1.x to 2.x, and the application management has been completely separated off from the Yarn resource management. And this also gives us much more performance boost in terms not only just scalabilities, and also Hadoop now is able to be running on top of Windows also, and we not only just substantially tested Yarn itself, we also substantially tested Yarn with the rest of the Yarn ecosystem, like Uzi, HBase, something like that. So the next release is Hadoop 2.3. This is the first post-GA release. We included some alpha features here, like the resource manager high availability, and the application history server, which is basically a separate server daemon sitting inside Yarn for serving the application request, for storing the application history server, and serving the current request for querying the application history server. And we also did a bunch of tests, bug fixes, and enhancements. I will cover more in the remaining slide. In April this year, we basically we released the newest release, a 2.4. We basically stabilized all these previous features, and we include some more stabilizations, like the preemptions in the scheduler, and also the container preserving recovery. AM application basically saying application master recovery with previous containers not being killed. So as people know, a resource manager is clearly a single point of failure. Resource manager can just crash for many reasons, and it can also be manually shut down for maintainers. And our goal is to make resource manager downtime invisible to end users. This means the applications that were running before resource manager crash should just be able to run, should continue to run without any interruptions after resource manager comes back up. And in the meanwhile, all these node managers that were inside the Yarn cluster should just be resync back with the new resource manager seamlessly. And basically, it has two stories. Like one is about the recovery of the state. This is saying the so because the resource manager crashed, it will lost all the state will just be gone. So we have to implement some way to just persist this kind of state, such that when the resource manager comes back up again, this state will be reloaded back to the memory and populate such state. And also the other is about the failover, how the resource manager is failing over from one instance to another instance. We have two resource managers, one active and the other standby. And the standby should just take over the leadership if the active one fails. This is the basically architecture, how this whole thing works. It's fairly straightforward. Like these node managers on the left side, are a pool of node managers, and these resource managers in the middle. One is active and the other is standby. And those two resource managers share the same state store. It's a pluggable state store. It can be Zookeeper, and also it can be HDFS. It is used for storing all the application state that the resource manager has. And there's a client which is talking with the currently active resource manager. So let's say this previous resource manager goes down, and so the standby resource manager should should automatically take over the leadership, and this is handled by the zookeeper itself. Zookeeper is kind of a coordination service, and so on such transition from the standby to active, it will first thing it does is to try to load this state that was earlier. So this is, the active resource manager will just periodically publish all the state into the central storage, and the active, the standby will, when transition to active, will pick up the state from the storage and populate such state. And in the meanwhile, all these node managers and applications and also plus the client will be redirected to the new resource manager, and this will be handled by the, which is called improxy, is a library which handles all the redirection logic. So if people want to talk with, if people want to implement their own application, this they can just use the application, this library, to talk with the resource manager, and all this logic will be implicitly handled. And there's a talk going on this afternoon, which is by Karthik and Xuan. They will talk about resource manager, have a little bit more detailing. The other thing I want to mention is the timeline server. This is basically motivated by the MapReduce job history server. So in MapReduce version 1 world, we have a separate MapReduce job history server, which is for storing the MapReduce job history and also serving requests when the client wants to query the history information of this job. They can go to this server for such information. And so we want to so because Yarn has become a generic platform, there are more applications coming on top of Yarn. We have Thais, Hive, and those things. We don't want to build each application history server for individual application. We want to build a very central history server to serve the request, to serve such. In fact, this kind of functionality is very common to these applications. They just store such history and serve such serve the client's request for querying such history. So the goal was to build a central history server to serve all the history requests and also to store all this history data for all kinds of applications. There are a couple of things I want to highlight here. This not only just applications itself, resource manager itself can also publish such kind of data into the timeline server, and they are doing a way as compose all this information into one entity and send this entity to the timeline server via the events. And the timeline server itself has a pluggable state store, which depends on it can be HBase or LevelDB or just HDFS, and outside the clients can build their own visualization tools with the RESTful APIs or just by mere RPC calls. And people are free to define whatever the entity, the data they want to publish to the timeline server, and they can build their own client for querying such data, such metrics from the timeline server. This is the basic workflow how this whole thing. So we have 2 apps and the resource manager, which periodically publish these events to the timeline server. And we also have some on the right hand side, the client can build its own app monitoring tool. And the Embody is a open source project which is used for managing and monitoring Hadoop cluster. And both of them can just use RESTful APIs or whatever they want, whatever information they want to from the timeline server, and build whatever visualization tool they want. And there's also a talk going on by CG from HondaWorks and Mayank from eBay about how to take advantage of such timeline server for historical information of the apps. Another thing I want to say, which is also currently actively working on, is about capacity schedule preemption. So I want to give a bit context is that capacity schedule is a schedule which allows people to define different queues for different dedicated user groups. For example, group 1 can submit applications only to Q1, and group 2 can submit applications only to Q2. And so just for batch cluster, and this queues, each individual queues has its own fixed amount of capacity limit. But for the batch cluster utilization, each queue can just go beyond its capacity limit if there's more resources available in the cluster. So if one queue has used up all its resources and go over its capacity limit and take over some resources from another queue, and if the other queue want to claim those resources back, if the other queue want to reclaim those resources back, and it has to wait for this for the earlier queue to release the resources themselves. So it can. So this is where the preemption comes in. This queue. So the preemption allows the queue to forcibly reclaim those resources back from the another queue without just waiting for those resources to be released themselves. There are like several steps. So the first thing is the capacity schedule will check periodically check whether the preemption is needed or not. If it is needed, it will within the queue, it will try to identify the applications to be preempted, and so for those to be preempted application, it will just issue those preemption requests for this application. And when the application gets such a request, it will pick the resources the application wants to release, and send such a request back to the resource manager, and the schedule itself can kill such containers on demand by the application. This is kind of a cooperative protocol. So the schedule itself won't just immediately kill these containers. It will wait. It will wait for the application. So if the application doesn't respond in a fixed amount of time, it will just go ahead and kill the containers. So this is basically flow that the scheduler first issues the preemption request, and the application responds back with the release resources, and then if the scheduler issues the request preemptions again, and the application doesn't respond, then the scheduler will just kill those containers forcibly. So basically, preemption gives us a balanced policy among different queues. If the one queue is go over its capacity limit, it will just be balanced again. Yeah. This is still work in progress. It's about container preserved AM recovery. Basically, so in the past release, when the AM shut down, those containers that belong to this application will just be killed along with the AM. But now we give a option for the AM we give a functionality that those containers that are belonging to the previous field AM will not be killed. So let's say this graph shows how this thing works. So this container 1, 2, 3 are belonging to the previous AM, and if the AM just shut down itself, the next AM will come back up and get those previous running containers from the resource manager, and this is done by the registration protocol. So these containers will basically return when the new AM register with the new when the registers with IAM. These containers will return back to the AM. So the goal was so in the MapReduce world, so it may make sense just to kill those MapReduce tasks because those are short-lived jobs. But in the world like like Hive, those are long-running servers like HBase. We don't want to kill the containers that were launched with if the application master itself fails, we don't want to kill those containers that were launched by the previous AM. This is the next couple of releases are going on, and there we are also doing the work preserving restart, which is a more enhancement of the resource manager high availability, and also we also enable Yarn timeline server to be able to run in a Kerberos authentically executed environment. And there's lots more coming, which Vinod will cover more of it. Yeah.
Excellent. Thank you, Jian. So much for the present. Let's look into the future. As I say, the future is already here. It's just that it's not uniformly distributed. So some of the features that I'm going to talk here, they're either in progress. We're working through them. So you'll see that some of them are kind of done, 50%, 60% of it, and we have big themes in terms of what we do. Clearly, it's a vibrant community. A lot of people are working in a subset of features, and the project itself gets pulled into different directions. But we have overall themes in terms of where we want to progress. One of the big themes is operational enhancements. Today, if you want to upgrade a cluster, you essentially have to bring it down, replace the bits, bring it back up, and in the meanwhile, applications which were running before, they would be lost. Clients would be forced to resubmit. You also lose existing work, right? So one of the big enhancement that we want to work on across the stack, not just in Yarn or even in HDFS, is to enable rolling upgrades, right? Bulk of the work to enable rolling upgrades in HDFS is already in, and Yarn is trying to catch up with that. And part of that is to make sure that when you upgrade Resource Manager, even it goes down, existing applications continue to run in a non-disrupted manner. Similarly, when you upgrade only node managers, you don't kill the containers, right? So those are the big big ticket items for enabling rolling upgrades. That is an effort that's underway. Suresh from Hortonworks and Jason from Lloyd, they're covering most of rolling upgrades more in detail in all of Hadoop. The next big theme is to enable other applications. We've been saying, Yarn is the data center operating system, which enables applications of all sorts of types, right? And we know MapReduce is already working. There are new apps that are coming on board, and with those new apps, new requirements also are coming up from Yarn's point of view, right? And that's what I'm going to discuss next in a couple of slides. We have work in progress to enable long-running services. We want to enable multi-dimensional resource scheduling, because imagine running a long-running service like a Storm or HBase on the same cluster as a MapReduce application. You don't want them to affect each other in terms of resource usage, right? There is stuff in there to make sure that both, the conflicting applications which have different set of requirements, you schedule them intelligently such that they don't impact each other. And the follow-up to that intelligent scheduling is to enforce that scheduling. Even after you schedule them intelligently, you need to make sure you go to the individual node and say, hey, there is an HBase long-running service running, which it has its own resource requirements, SLAs. Make sure you respect them. So there is enough isolation work that needs to be done in Yarn. Some of it's, again, like I said, some of it's there. We need more work to do. And finally, web services. Specifically in long-running services, you can kind of run them already. It's no different from running, say, a MapReduce job for 7 days, right? So you can run them, except there are a few holes here and there about logs, because you can imagine, right? For a MapReduce application, once it finishes, you can gather logs. But a long-running service, there is no termination time. It'll be running for a month, 3 months, or a year, depending on the kind of service you're running. So you have to handle logs separately for them. Similarly, security. Today, we have a limit everywhere in the system, not just in Yarn, even in HDFS, with respect to security, saying you cannot run jobs longer than 7 days. If you try to run them, they'll fail after 7 days, because they have security requirements, a bunch of things. So we have to handle them when you want to really handle handle long-running services in a first-class manner, right? Similarly, management and monitoring. A regular MapReduce application or test application, it runs for a while, it goes away, you get statistics collected when the application finishes, but you can't expect to do that. If you have a Storm application running in a Yarn cluster, you want to continuously monitor it to figure out how the load is, how if there are any problems with nodes, or if you want to split a single worker into multiple workers, things like that. So there is enough monitoring and management work that's needed. And here we are kind of looking to tools like Ambari, which already have built management and monitoring functionality to deploy services today, right? And finally, resource sharing. I'll discuss a little more in that. There's a talk by Sumit Mohanty. He's talking about bring your services on Yarn. That's going to be covering mostly long-running services and Project Slider, which is specifically built to enable all these services, right? I was hinting at multi-resource scheduling. Today, Yarn natively understands that your application needs 3 GB of RAM on 400 containers. It natively supports that. You can go and say, I want 3 GB or 5 GB, and different people have different requirements, and it schedules them so that everybody gets their own share, right? But it also needs to support things like CPUs. How many cores do I need? How much CPU do I need? How much disk capacity do I need? What IOPS do I get? And even some share of network. So that's the overall list of things that we need to enable to really support applications to request arbitrary resources. We started with memory, it's already there. CPU, we are kind of 60, 70% through. The biggest patch to enable multi-resource scheduling is in. We need to bake CPU stuff more in. The next one in the list is disk throughput and capacity and IOPS. And like I said, it's not just enough to do scheduling. You also need to enforce them. On any given node, you have a bunch of CPUs, RAM and disks, right? Containers can be running from different applications, from the same application. They may have different requirements. One may be asking for 3 GB, 2 cores, but someone else may be saying, hey, I'm Storm application. I want 7 CPU cores on this machine. So you need to make sure that all of these guys who essentially have conflicting requirements or different varied type of requirements, you want them to coexist on the same node. And that's the promise of Yarn, right? So in order to do that, again, like I said, memory is a first-class resource. So we have memory-based monitoring. We also are trying to move beyond a simple memory monitoring model and enable something like C groups, using which you can control memory, control CPU, and stuff like that. And we don't want to reinvent all of it. Elsewhere, people have developed all these features on individual platforms like Linux and Windows. We're just leveraging all of those. An interesting direction for this is Docker. Docker is increasingly being used as a container mechanism. So we also have a mini project inside Yarn to integrate Docker into Yarn. Our friends from Altiscale, they're working on it. Eventually, you can even imagine virtual machines running inside Yarn, because that's the ultimate level of isolation you can guarantee to any given application, right? So there are many ways you can run even VMs inside Yarn. Sanjay Radia, he's also giving a talk specifically on how you can make virtual machines run in such an environment. So we have about 8 minutes. Let me go through this. So bunch of miscellaneous features. I put them together. Each of them warranted to talk in themselves. One of them is application SLAs, where you want to say, hey, I know my workload. I know it runs at 6 o'clock every day in the morning. I know that it'll run for 2 hours. It'll take 50% of the cluster. I want predictability. I don't want some other application to come at 5:30 in the morning, take the cluster, and then affect me, right? So that's a feature that our friends at Microsoft Research, they're working on. There is node labels wherein some of the customers and organizations we talk to, they have specialized hardware or specialized software that's installed only on a subset of machines, and they want to control those machines to be only used by a subset of users, right? Imagine something like a GPU and an application that explicitly takes advantage of GPUs. You want to use those machines only for a subset of users who really have those requirements. So node labels is the feature that enables that. And similarly, there's a concept of node affinity and anti-affinity. Some applications can say, hey, don't run me on this machine where the application from that user is running, because I know beforehand or offline that he and I will conflict for whatever reason, because of resources or various dimensions, right? So that's anti-affinity. You can explicitly go and say, hey, don't run my application containers on this set of machines where something else is running, right? We also are building lots of tools to help applications, admins, and one of them is online queue management. Today, the queue management is pretty prehistorical times. You go and edit config files and send a signal to the resource manager. We want to put it in front of the admins to say, hey, this is a central place. This is how the system is configured today. Go and change it. Give tools to help admins understand their current usage and stuff like that. So we're building some of that so that admins can get feedback on how their resources are getting used, so that they can make future planning, right? And finally, we're also implementing web services everywhere. Today, if you want to write an Yarn application or submit one, you need to have all of Hadoop as a dependency, which is something that doesn't fly at all. We want tools and third-party organizations to be able to submit applications, whether within the cluster or outside the cluster, through web service, so that it kind of is a way to reduce the friction. Today, the friction is high because we say, hey, only Java, put it in class path. That's the only way you can submit it, right? A quick, I've talked about a lot of projects, right? So in the Yarn ecosystem, as we started moving towards stabilization tools, separate frameworks and applications have come up. We still have classic MapReduce that still works, and like I said, it has lots of performance enhancements, improvements on top when it runs on top of Yarn. We also have Apache Tez, which is catering to both batch and interactive processing. It spins up containers, keeps them around so that the end user has a very interactive experience. We also have Slider, like I said, go to the talk, using which, if you have an existing application without changing any of your code, imagine Memcache, imagine something like HBase, which is already written as a separate project, and if you want to bring that to Yarn, if you want to run it on the same cluster as your regular MapReduce batch jobs and stuff like that, the Slider is the way to go. And you can bring those services without modifying your existing code. You can write a bunch of schema definition files and then say, hey, go and run this. That's what Slider helps you in. We also have frameworks like Storm and Samza coming in, which enable stream processing, and Jira for graph processing, and Spark for iterative processing. We also have people building frameworks on top of Yarn to write Yarn applications, because Yarn is at such a low level that writing a new application is kind of complex. That's where there's Slider, other frameworks like Twill and Reef, they kind of ease the whole process of writing new apps. So we have 4 minutes. A quick recap. This is a summary slide. If you have to take away something, this is what you should take away, right? Apache Hadoop 2 is definitely twice as good as or better than Hadoop 1. So even if you don't care about anything else, upgrade to Hadoop 2. It's an exciting journey ahead. We built this with not just present and past problems. We built it for the future. And so Hadoop is no longer a one-trick pony or elephant. You can do a variety of applications. And finally, a bunch of features are coming in. People have recognized that, hey, we have this beautiful platform. Let's build tools and frameworks on top of it, which will give me more out of my cluster, right? Before we finish, a couple more things. I and Arun collaborated with Doug Idline, Joseph, and Jeff Markham on a book. This book will help you getting introduced to Yarn. It'll help admins how to manage and set up Yarn clusters. It also helps people in developing new applications on top of Yarn, or how you can use existing frameworks which are already modified, like Pig and Hive and Uzi on top of Yarn. I think there's a bookstall where you can get a 30% discount on the book, and 40%. We also have accompanying video lectures. So you can get that, or if you already have a Safari online account, you can access both the book and the video there. And finally, for those of you who are still experimenting with stuff, who don't want to kind of affect your existing clusters, you can use the sandbox. Essentially, it's data center in a virtual machine. You can learn about Hadoop, Yarn, everything, the entire Hadoop ecosystem, and build proof of concepts, build applications, and given the way the whole architecture is built, you can just run the same application in a real cluster with perhaps minor configuration tweaks. And that kind of closes my talk. We have 2 minutes for QA. Sorry. Yeah. Do you mind coming here? Let me stop all the guys who are leaving. Didn't I say I have a couple of books to give away? No, nobody's stopping. So the question, I guess, is there is state in the resource manager that's being stored in a central store. So resource manager needs to, like I said, you don't want applications to be affected whether the resource manager is up or down, right? So it kind of stores the minimum amount of information that's needed to, run the applications in the event of a crash or a failover. So most of the data is about application metadata, who submitted it, where, how much resources and stuff like that. Location of? So the rest of the application stuff should be handled by the application. If you're running a Storm application and you have a bunch of sports and boards running somewhere, you are supposed to remember where they're running. Location of the application master. Application master is not So, we never give a guarantee that application master will run on a specific host. So when we come back, we will, we might run it somewhere else, or if rolling upgrades are enabled, we will not even kill the application master, right? So we don't even need to access the state. So maybe we should take that offline. I can definitely give you more detailed answers. Yeah. Do you mind using that? Oh, I see.
We have application use Hive script and cascading running on one stream now, and we are going to migrate to two. So there are some best practice.
So so the question is, we have existing applications like big queries, Hive scripts, Uzi workflows that are running on top of Hadoop 1. Do I need to do anything? No, that's what Jian was saying. You can run existing Hive scripts, existing pig scripts on top of Yarn, assuming that you're working against some version of a pig and Hive, like pig 10, Hive 13, they all work on top of both Hadoop 1 and Hadoop 13. So essentially, you don't need any change. You'll get a lot of performance improvements, but that's about it. I can take the other questions offline. I think we just exhausted the time. Thanks.